Hello friends, my name is Sarah Vandorf, and this is part 2 of 3 videos that I am making about circles and bringing movement and how you bring circles into your math classroom. I am writing about these at my website, sarahvandorf.com. I'm also going to be talking about them on social media. I'm particularly active on Twitter, so I hope you'll join me there. And if you're finding me right now on Twitter or on YouTube, I hope that you will click subscribe and join me as I am talking about mathematics in this arena as well. So I am talking about circles, which always come up on Pi Day, but I have some Pi Day pet peeves. Like I think how Pi Day gets played out in many places. Like there's a new pie shop, brand new. It's going to be great. I've gotten some of their pies previously before they've even opened up their shop, and they're all excited about Pi Day because Pi Day is March 14th and they're selling PIE and they're like, this is also mathematical PI. But really, I think if you ask most of the people in Minneapolis where I live why pies and pies, why this day is March 14th, they can't say a whole lot. And I think in our math classrooms, most students, all they can say about pi is 3.14. They don't even know that pi is this wonderful, beautiful, irrational number that goes on forever. And even if they know that, they don't know much more about pi past that. And so how pi is celebrated, I think, brings to students a limiting view of the magic of Pi Day. And so in this second video, I want to talk about how I use movement to really build on that idea of the relationship that pi is. I am very passionate. This is the definition of math that I use in my classroom. This is a poster that hangs on my wall, that math is a study of patterns and relationships. And I want my students to see the relationship, pi as a relationship of some things. And I want them to be able to describe that relationship because my students are mathematicians, and every day in my classroom, including March 14th, I want my students functioning as mathematicians. I don't want them just citing digits of pi. If they're doing that, that's great. I don't have a problem with that. But in addition to that, I want them to understand this beautiful relationship that and what pi is. And so I want them noticing and describing and generalizing things on days. So if you don't have an idea for Pi Day, and this, by the way, these ideas in this video aren't just for Pi Day, they're for any time. I want to give you some ideas of how you can bring in movement to talk a little bit more about what pi is and talk about these relationships, these ratios, this relationship between the circumference and the diameter that exists that you eventually might do other things with and graph and figure out that the pi is just a rate that describes how the diameter is changing in relationship to the circumference. And have your students look at that. So here's what it looks like in my classroom. In video 1, I talked about how I get my students up and moving and standing in the shape of a circle without using the word circle. If you're wondering how I did that, go back and watch video 1. But once I have them up and in this shape, and we've talked about what a circle is, we will also start to define some of the words that define circles. So for example, we'll talk about that we are all standing on the circumference of the circle. And we'll talk about that being the distance around the circle. In order to make that circumference in that circle as tight as possible, I'll have some of the students step in, say take a giant step forward, and have all my students take a giant step forward so that we're standing as, relatively close together. We don't have to be touching, but that we're pretty close to one another. And we'll look at this and say, what is the circumference of the circle? And so the unit we're using is the width of people. And so we'll talk about that the circumference of our circle is 33 students. And that the circumference is the width of 33 people, 33 students in the case of our picture. And so after we do that, I'll start to ask students one at a time to come and stand next in certain places along the things. What you can see is happening is I'm actually having them stand on the diameter. We'll talk about this being the diameter, and that now all of these students are standing on the diameter of the circle. And then we'll talk about the fact that there are 11 students standing on the diameter. And then I'll ask, is there any kind of relationship between all the students that we had standing on the circumference, those 33 students, and the number of students that it takes to make the diameter? And as students look at those numbers, what is amazing is ultimately, I picked a number that it's a multiple of 3 as a circumference, but even if it's not, this relationship that students will see is pretty close to 3, and that we will get this number close to 3, and that this, I'll talk about, do you think this is true for any size circle? And so we'll imagine making the circle bigger and smaller. And if the circle was bigger, we would need more students to make the circumference and more students to make the diameter. Do we think that that ratio would still be 3? And we'll leave it there in wondering for a little bit, because we'll explore it other ways mathematically when we take a seat. But ultimately, I want my students, when we're standing, to say, you know what, I think the ratio of the circumference of any circle compared to the length of its diameter is around 3 people on the circumference for every one person that's standing on the diameter. I want them to look at that as a ratio or a rate of a comparison of things that we're doing. It is awesome when you start exploring circumference and diameter and that relationship. When you go back to sitting in your seats or wherever else you're doing the mathematics, students will continue to talk about that time that we were standing in that circle, and we'll have a memory connected to that that they can then connect to work that they're doing when we might craft this relationship or do other things. There's some other ways that I explore this ratio other than just having a stand with students. Like you right now, I want you to think, what are other ways, incorporating some movement, that you could have students explore that ratio of? I think there's 3 diameters in every circumference. So here's another way that I do. Let's say, it's there's a virus going around the world right now as I'm making this video, and it's getting everybody alarmed, and we don't want to get too close. So let's say we're at school and I don't want to pull everybody in. Here's another way that we could visualize pi as this ratio. And so this way of doing it is me using a length of rope, and I have students use that length of rope all the way across from one end to the other through the center. And then I get out a pair of scissors and cut that off, and I have them keep holding that. And then we cut a second piece of black rope, the same length as the diameter. And then we take that and we put that around the circumference, the edge of our circle. And then I take another color of rope and I cut off another piece that's the same length as the diameter. And we measure that out to go another part of the way around the circle. And then I get out a third color and we do the same thing. We cut that green rope to be the length of the diameter of the circle. And then we do that. And what students will realize is these 3 diameters, these 3 pieces of rope will almost make it all around the circle, but there's this little piece that doesn't quite get filled in. Now, most of you watching this are probably math people and know that the number of diameters in any circumference of any circle is approximately 3.14159. It's an irrational number that goes on forever, but it's 3 diameters and a little bit more. And so that's what I want my students looking at, is describing that relationship, that the circumference of any circle is equal to 3 diameters plus a little bit more. We'll eventually get to what that little bit more is, but this is just kind of our first introduction to it. And so when they start to see 0.1415926, so on and so on, that number physically has a place for that to go in their head. So this is just 2 different ways that I get this idea of circle, that pi is a ratio, and that the circles have these ratios. Every circle has this really cool ratio embedded in them, how I make that happen. This is, again, part 2 of a 3 video series on circles and movement. And so I hope you'll check me out. I'm writing about these videos at sarahvandorf.com, so you can read more and then you can download some resources there. But if you follow me on YouTube, I hope you subscribe or click like, and you'll get notifications about when I make videos about mathematics. So thank you for joining me.